In recent years, psychedelic drugs have garnered significant attention for their potential therapeutic applications. However, the phenomenon of bad trips, intense, distressing experiences that can occur during psychedelic use, remains a crucial area of concern and study. This article delves into the science behind bad trips, exploring their causes, effects, and the latest research findings on the role of neurotransmitters in these experiences. Understanding bad trips. The term bad trip is colloquially used to describe challenging experiences during psychedelic use. Researchers prefer the more neutral term, challenging experiences, to encompass the range of difficult psychological states that can occur. These experiences can manifest in various ways, including increased heart rate, panic attacks, sudden mood changes, e.g. anger or sadness, ego dissolution or ego death. Ego dissolution, a particularly striking aspect of psychedelic experiences, involves a dramatic alteration in self-perception, where individuals may lose their sense of self entirely. While not inherently negative, ego dissolution can contribute to dangerous situations, including suicides and accidental deaths in extreme cases. Prevalence and duration of bad trips. Bad trips are not uncommon among psychedelic users. Research indicates that approximately 40% of individuals who have used psychedelics have experienced a bad trip at some point. What's more concerning is that the negative effects of a bad trip can persist long after the drug has worn off. In one study, nearly 9% of participants reported functional impairments, lasting more than a day following a bad trip. Another study found that some users experienced increased anxiety, difficulties with social interactions, and cognitive problems for weeks or even years after using psychedelics. These findings highlight the importance of understanding the mechanisms behind bad trips and developing strategies to mitigate their risks. Neurotransmitters in psychedelic experiences. The role of neurotransmitters in psychedelic experiences has been a subject of intense scientific inquiry. While serotonin has long been associated with the effects of psychedelic drugs, recent research has shed light on the importance of another neurotransmitter, glutamate. Serotonin, the classic psychedelic neurotransmitter. Serotonin, often linked to feelings of happiness and well-being, has been the primary focus of psychedelic research for many years. Psychedelic drugs are known to interact with serotonin receptors in the brain, which are involved in mood regulation and memory formation. This interaction is believed to be responsible for many of the positive experiences associated with psychedelic use. Glutamate, the new player in bad trips. Recent studies have identified glutamate as a key player in the occurrence of bad trips. Glutamate is an excitatory neurotransmitter that acts as an on switch for various activities in the central nervous system. While glutamate is ubiquitous in the brain, its levels in specific regions appear to correlate with negative psychedelic experiences. A groundbreaking study examined the relationship between glutamate levels and challenging psychedelic experiences. The research involved participants with previous psychedelic experience, half of whom were given a psychedelic drug, while the other half received a placebo. MRI scans were conducted when the drug effects were believed to be at their peak. The study's findings revealed a significant correlation between glutamate levels in the medial prefrontal cortex and negative ego dissolution experiences. Participants with higher glutamate levels in this brain region were more likely to report anxiety and distressing alterations in self-perception. The medial prefrontal cortex and emotional regulation. The medial prefrontal cortex, located in the frontal lobe of the brain, plays a crucial role in emotional regulation. The elevated glutamate levels observed in this region during bad trips suggest a mechanism by which psychedelics may trigger anxiety and other challenging emotional states. Glutamate's role in controlling stress-related behaviors provides a plausible explanation for the heightened anxiety experienced during bad trips. By activating stress responses in the medial prefrontal cortex, elevated glutamate levels may contribute to the intense and often overwhelming emotions associated with challenging psychedelic experiences. Non-neurochemical factors contributing to bad trips. While the role of neurotransmitters is crucial in understanding bad trips, several non-neurochemical factors can also influence the likelihood of challenging experiences. Dosage. Higher doses of psychedelic substances are associated with an increased risk of bad trips. The lack of regulation and standardization in illegal psychedelic use makes it difficult for users to control dosage accurately. Set and setting. The concepts of set, the user's mindset and mental state, and setting, the physical and social environment, are considered critical in shaping psychedelic experiences. A negative mindset or unsafe environment can significantly increase the risk of a bad trip. Individual differences. Factors such as personality traits, past experiences, and mental health history may influence an individual's susceptibility to challenging psychedelic experiences. The potential value of challenging experiences. While bad trips can be terrifying and potentially dangerous, some researchers and users argue that challenging psychedelic experiences may have value under certain circumstances. Psychological insight. Some individuals report that bad trips have helped them confront repressed emotions or memories, leading to personal growth and self-understanding. Perspective shifts. Ego dissolution experiences, though often distressing, may provide opportunities for individuals to examine their lives and behaviors from a different viewpoint, potentially catalyzing positive changes. Therapeutic potential. The ability of psychedelics to induce profound psychological states is one reason they are being studied as potential treatments for mental health disorders such as depression, anxiety, addiction, and PTSD. It's important to note that these potential benefits do not outweigh the risks associated with uncontrolled psychedelic use, and any therapeutic application should be conducted under strict medical supervision. The future of psychedelic research. As our understanding of the neurochemical mechanisms behind psychedelic experiences grows, so does the potential for developing safer and more effective therapeutic applications. Future research directions may include developing methods to modulate glutamate levels or activity to reduce the risk of challenging experiences during psychedelic-assisted therapy, investigating the long-term effects of psychedelic use on brain chemistry and mental health, exploring the interaction between different neurotransmitter systems in shaping psychedelic experiences, refining protocols for set and setting in therapeutic contexts to maximize benefits and minimize risks. Conclusion: the discovery of glutamate's role in bad trips represents a significant step forward in our understanding of psychedelic experiences. By elucidating the neurochemical underpinnings of challenging psychedelic states, researchers are paving the way for safer and more effective use of these substances in both recreational and therapeutic contexts. However, it's crucial to remember that psychedelic drugs carry significant risks, particularly when used outside of controlled settings. The potential for long-lasting negative effects underscores the importance of continued research and the development of evidence-based guidelines for psychedelic use. As we continue to unravel the complexities of the human brain and its interactions with psychedelic substances, we may find new ways to harness the potential benefits of these powerful compounds while minimizing their risks. The journey to understand psychedelics and our own consciousness is ongoing, and each discovery brings us closer to a more comprehensive view of the mind and its extraordinary capabilities.